For rational inequalities, we're going to treat them the same way that we do the polynomial inequalities. We're going to rewrite this as an equation instead of as an inequality. Oops, follow my own advice there. And solve that equation to find some of our key points. And then there's another key point that we have to identify besides the solutions to this equation that I'll explain in a moment. But to start off with, to solve this equation, I'm going to multiply everything by the common denominator over 1. So our only denominator is x minus 3, so I'm going to multiply everything by x minus 3. So that gives us x minus 2 equals negative 3 times x minus 3. So I'm just distributing this all the way through the problem. So I've got x minus 2 equals negative 3x plus 9. So now if I move the x's to the left, I'm going to get 4x over there. If I add 2 to the other side, I get 11. And so then if we divide both sides by 4, don't panic, we get x equals 11 fourths. And so for our key points, we put them over here. It may seem as though we only have one key point, which would not be very interesting, but there is a second key point, as I alluded to. And that second key point is any number that results in division by 0 in our original problem. And so if we go back to our original here, if we look at the denominator, x minus 3, hopefully we recognize that x equals 3 would be a problem in that inequality because we would result in division by 0, which would mean a hole would open up in the universe and we'd all get sucked in and die. So in this case, we actually have two different key points. One, the solution from the equation that we solved, and then one because of the result of division by 0 if x equaled 3. And so now I'm going to take those two numbers, 11 fourths, which is 2 3/4, so it's a little bit smaller than 3. So I've got 11 fourths and 3 as my, let's try that again, 3 as my two key points on my number line. I know I'm going to have open circles, so it's just a matter of which of our regions, region 1, 2, or 3, are going to work. And really what we could do is we could cheat a little bit here since we only have these 3 regions, and we can go ahead and just plug something in the middle. If the middle works, then that's going to be the only part of the problem that works. If it doesn't work, then we know both of the outsides will work. So it's a little bit tricky on this one to do this, but again, we're not really worried about the exact answer. We just want to check to see if it's a true or false statement. So again, 11 fourths is 2 3/4. So if we think of this in decimal terms, 2.9 would be a number that would be in between 11 fourths and 3. So if I plug in 2.9 into my inequality, I've got 2.9 minus 2 over 2.9 minus 3 has to be greater than negative 3. So I've got 2.9 minus 2 is going to be 0.9. 2.9 minus 3 is going to be negative 0.1, and then I want that to be greater than negative 3. So if I divide that, 0.9 divided by 0.1, well, that's going to be negative 9, and that is decidedly not greater than negative 3. Negative 9 is smaller, it's a bigger negative. So that means I am not going to be graphing in between these two. I'm instead going to be graphing on the outside. And so I'm going to extend my graph in both directions from those boundary points, and then I just need to write my algebraic inequality. And so this one's going to show up as an OR problem. X is less than 11 fourths, or x is greater than 3. And so we have our solution to our rational inequality.